Hello, everybody. We're super delighted to have you all joining us for this very special demo day. We're just going to wait another minute or so while people trickle in, because I know there's a load of us on the call today, and we're all really excited to have our students' final presentations in front of your eyes. So while you all get settled in, do just make sure that as you come in, get yourself on mute. You can turn your camera on if you would like, but there's no need to if you're in a meeting room or if you're in a shared office. No need to have your camera on if you're sneaking this in on your lunch break. So as I said, we'll get started in about the next 30 seconds or so, and we'll kick things off with an introduction from myself and from Steve. Speak to you soon. All right, and I think with that, we are looking like the number of people who've signed up is here. Super, super exciting to have you all join us today. Really appreciate it. And thank you for joining us on a Friday, just before the bank holiday as well. Hopefully everybody has some wonderful plans this weekend. Looks like the weather's going to be okay. Hopefully it is for you all as well around the country. Welcome to Demo Day, and of course, welcome to Makers as well. I'm Sean, I'm the events manager here at Makers, and I'm the least important person on this call today because all of the students are going to be joining us and sharing their very exciting final projects. If you have joined and you are struggling to find your mute button or your camera button on the call, do give us a shout and you can pop that into the chat. There's also a chat functionality as you go throughout the day. Our team is really excited to be presenting to you. If you have any questions at all throughout the presentation, there'll be Q&A just at the end. And so if you have any pressing questions, do just drop them into the chat. And if we've got time, we'll get to them as the presentations continue. So welcome to Makers, as I said. We're so excited to have you here. We are absolutely about building the future, and we're about transforming lives and organizations by bridging the tech industry needs to that undiscovered talent. And we're so proud of some of the fantastic presentations that are coming down the road to our audience today. I know that some of you are joining from around the tech industry, some of you are in tech roles within industries outside of tech, and you're really eagerly anticipating some of these presentations. So with that, I am done. My job is done here, and I'm going to hand over to Steve, who's going to introduce himself and then kick things off properly. So Steve, I'll hand over to you.
Perfect. Thank you, Sean. Hi, everyone. I'm Steve. I'm actually one of the coaches at Makers, and I also had the pleasure of taking the current cohort that you're about to see through their final project. So, yeah, so just to talk about why Makers, and really Makers is about taking anyone who wants to get into tech and then giving them the tools to make that transition. It's a super intense learning experience, and all of the devs you're going to see today have come from a variety of different backgrounds and basically started from either nothing or having very little coding background, and now, as you're going to see, have been able to build a full stack application from scratch. And yeah, the first thing says, oh, sorry, you want to go back, Sean? Sorry. Yeah, just to you can have a look at this, but yeah, you know, we try and get makers the ability, give makers the ability to kind of face any challenge, not solve any challenge, but at least give them the tools and the skills so that as they go on through their careers, they're really able to kind of yeah, approach everything from a mindset where they can attempt it and they can solve it. And yeah, I think Sean, if you could go to the next slide, please. Amazing. So I guess as a coach, this is probably the most important slide that I like to talk about. I think Makers isn't really just trying to create devs that do really well on this bootcamp, but are trying to create devs that do well throughout their whole careers. And this is kind of the crux of it, having a growth mindset, embracing challenges, you know, having persistence, resilience. And, you know, each week, learners are faced with these brand new topics that they've never seen before, and it flashes by them new challenges. And they've not just really grown technically, but they've grown the ability to kind of face every week as it's come by. And yeah, I feel like collectively you've all really rose to the challenge. So yeah, it's amazing to see the growth in growth mindset, let's say, is amazing to see. And yeah, I think the last side as well, cultivating mindset that failure is your opportunity for growth. And you'll see that as you go through your careers. And amazing. Sean, could you slide one more time? Finally, yeah, Makers is a community, and we really like to support people that didn't have that fair chance to get into tech. And you'll see it's something that we're passionate about. Makers has a lot of alumni who are really working on this still, and we're part of a lot of different organizations that are trying to get people into tech who didn't have that chance. Amazing. One more click, please, Sean. All right. So yeah, thank you for listening to my little spiel. I won't talk for any more longer because I think it's not about me. It's about the people that have gone through the 16 weeks. Um, and yeah, for me, it's been nice to see you guys get up to scratch, uh, start from scratch, sorry, and now to build these kind of really interesting projects. For everyone that's listening, everything that you see here today, the ideas, the research, and the execution has pretty much entirely been crafted by the people that you're going to see. We do a lot to help and guide them through these last 2 weeks to get the project into working shape, but it's predominantly their efforts that got them here. A lot of them had to build using new technologies, new frameworks, for example. And yeah, they've had to really use all of the things that they've learned and use a lot of, I guess, like professional developer processes. We really encourage them to build this as if they were working on a team in any company out there. And yeah, I guess I hope to all the people that are about to present, I hope you're proud of the achievements that you've made in the last few months because it's really nice to see. Okay, so without further delay, I'm going to introduce you to the first team, which is StyleSync. So whenever you're ready, StyleSync. You can see a slide, but if one of you is talking, you might be on mute.
That's me. Great
Okay,
start.
go on.
Let's kick it off. Okay, imagine this. You've got that big event looming on the horizon, or maybe it's just a fun night out with your friends. And as the date inches closer, you're standing in front of that closet, you're staring at rows of clothes and asking yourself that age-old question, what on earth do I wear? Well, the struggle of decisions. But hold on tight, because we've just got the solution for you. So introducing our game-changing wardrobe app, your ultimate lifesaver in those moments of colour confusion and style stress. Say farewell to fashion dilemmas and hello to the effortless chic with just a tap of your finger. But before we whisk you away on that tour of our fabulous wardrobe app, where fashion crises vanish quicker than yesterday's trends, let's take a peek around the scenes of our decision-making process. We began our wardrobe app journey by carefully selecting our technology stack, and after extensive deliberation, our team decided on a Node.js for the backend, MongoDB for the database, and Swift for iOS development. Node.js stood out as asynchronous operations, enabling real-time updates crucial for our app. Its single language, advantage streamlined development, complemented by extensive NPM ecosystem. MongoDB's flexibility and JSON-like documents seamlessly integrated with Node.js, so providing that scalability to accommodate user growth. For iOS development, Swift emerged as a clear choice. Its native performance, seamless integration with iOS features, and robust tooling from Apple made it ideal for building a responsive and feature-rich wardrobe app. Our decision-making process emphasized collaboration, utilizing visual tools like Figma and Excalidraw for brainstorming sessions. We adopted an incremental approach, refining our ideas throughout the development process. Regular stand-ups and afternoon retros were conducted throughout the week to ensure effective communication and continuous improvement. Backend development was powered by Node.js and MongoDB and prioritizing seamless data management and security. we utilize JWT tokens for authentication, bcrypt for password hashing, and implemented robust controllers and middleware for security measures. Image uploads were efficiently managed through GridFS, so converting base64 encoded data into readable streams. Asynchronous file handling and error management was seamlessly integrated, facilitating the handling of large files in MongoDB. Overall, our approach aimed to create an efficient and user-centric wardrobe app.
When it came to the front-end development, we wanted to use Swift to create an easy-to-use app. It had a smooth design, and we wanted it to be an easy way to visualize how each screen page would actually look on the actual app. We enabled sign-up and login functions to be able to allow logged-in users to only access certain features, whether it be add an item or favoriting that exact item. We want to use also to have the ability to add an item and display it. For me, I have a lot of clothes, so I feel like having the items showed up for me is great to visually have. They can also filter their search by favoriting an item and liking it and seeing it on that page for easy access. We faced some challenges during this project. We had to make sure the backend and front were very much in sync, and that was us using Postman to then make sure the responses were correct. I believe that using Swift was a learning curve for us to actually, in the future, have a much better understanding how it actually works.
So I'm going to show you a demo of our wardrobe app. So when we enter the app, we land at the homepage where we have two options, sign up and login. So I'm going to go ahead and sign up and create a new user, entering an email address, a password, and the username. Once I sign up, I'm able to log in. So for the purpose of this demo, I'm going to use I'm going to log in with the user that we already created because we needed to save some pictures of clothing in that account. So I'm going to use this user. So when I log in, I land in our dashboard. So here, let's look at the tabs first. So we have a tab, My Wardrobe, which include all our clothing items that we've uploaded. We are able to favorite items. So for example, we're going to favorite this first two, and we can find them here in our favorites. So if I unfavorite boots, then it's gone from there. Then I'm able to add an item, a clothing item to my wardrobe. So I can upload an image by clicking select image. So it takes you to your photo album. So I'm going to add, sorry, a pair of shoes. Just going to call it red heels. I'm going to define what category of item it is. It could be a top, a dress, a bottom, or shoes. So this is shoes, and I'm going to give it a few tags to describe it. And these tags are useful later when we generate an outfit. So we can put some criteria to research an outfit. So these heels are quite smart, I would say. Could use them for summer or winter even. So if I add this to my wardrobe, we have a little alert. Your item is added to your wardrobe, and you can see that a pair of heels is in my wardrobe now, and I'm able to favorite it, and it will be here. We can add something else. Let's now add different item. We can add this jumper, for example. Just call it jumper. Top. It's quite casual. I know it says for winter. And the item is added to my wardrobe. You can see it. It's come at the bottom. Let's now have a look at how to create an outfit. So we have two options. We can customize it by selecting some tags. So for example, I want something smart for winter time. We'll click generate outfit. This is what it would generate. Or we'll generate something else. Let's see, we could generate something casual for summer. So what we'll get. And the second option is to pick your items directly from your wardrobe. This is my wardrobe, lots of items here. And I think I'd like to select this top with hands and with sandals. Yeah, for general outfit. Outfit is created, and we can log out clicking here. That's for the demo. Thank you.
Bill, if you're trying to talk, I think you're on mute.
That's my wardrobe. So if anyone wants any advice on clothing, on any new frocks, please let me know. Anyway, moving on, reflecting on success and opportunity for improvement is really important, I think, especially after projects, and certainly something we've learned over the last 16 weeks to have a reflection on things and certainly successes and obviously things of opportunities of improvement. Our commitment to delivering value guided our decision making and feature prioritization and resulting in a wardrobe app tailored to our users and needs. Clear and open communication among the team facilitated smooth collaboration and decision making and ensuring everyone was aligned and informed throughout the project. Embracing a culture of continuous learning embedded us to adapt quickly to new challenges and opportunities and leading to them ongoing improvement and innovation. Our code was readable, reusable and efficient, and that lays a solid foundation for future development and scalability. There were a few things for improvement, and in hindsight's a wonderful thing if we have more time, but better user interface. So while our app was certainly functional, there's room to make an interface more interactive and user-friendly. So by implementing features such as user comments and favorites can enhance user engagement and satisfaction. Rachel mentioned a great feature, which is a weather feature. Incorporating a weather forecast function could elevate the app's utility. So it allows users to plan an outfit based on weather conditions. So integrating weather maps could provide real-time data for more accurate outfit suggestions. And although testing was completed, there was an opportunity to enhance our approach to TDD, so ensuring comprehensive test coverage and early detection of potential issues and improvement overall code quality and stability. Thanks for your time, guys. Hope you really like the app.
Amazing. Thank you, StyleSync. Really appreciate that. I love the app. I think it's very slick, and I personally think I need it, so I appreciate it even more. I'll ask one question to the team, which is, what are you guys most proud of about your app? And not necessarily just about your app, maybe just as a team, what do you feel most proud about now that you're here?
I'll start off, and I'll be saying right at the start when we were looking at our sort of stack, we had a real conversation because over the last 16 weeks we've been given the opportunity to try loads of different things such as Python, React, etc. And at the start we had different views on what to use. So for me personally, I was like, oh well, Java and Node.js because that's what we used, and I like React. I didn't have a good experience with Swift. So some people didn't. But then when you look at a project like this and sort of thinking, well, what do I want to use? You have to look at the bigger picture and trust other people's opinions. So using Swift and having that user interface so you can upload pictures to it was evident in here how it was probably a better solution to have that. So for me, it was about having that open and conversation and listening to others' opinions and not just saying, no, I want X, Y, and Z and coming together.
Amazing. Yeah, I think I felt that from the whole team. There was definitely that cohesion. I'm also going to leave the floor open to one more question from the audience, if anyone wants to ask StyleSync a question. Can be anyone, by the way, even people who've been on the course.
We haven't got time, Steve. Move on, my man. Thanks.
All right, we'll leave it there. Perfect. Thank you again. Next up, we've got Team Neurons.
Hi, everyone. I'm just going to wait for my team member to share the screen.
Getting that up. Oh man, I just did it all and then clicked cancel. Oops. There we go. Can you guys all see that good?
Yeah.
Perfect.
So the project we've been working on for the past 2 weeks, we've named it the Neurons, and meet our very cute friend called Henry Roy, who's been with us throughout the journey. Can you skip to the next? Can you skip to the next slide, please? So this is a web application, and what it does is essentially it allows users to track their cognitive and emotional energy levels. It's mainly designed for people who are neurodivergent because they react uniquely to different activities, and this would allow them daily monitor their energy levels.
So we started our project with our kickoff meeting where we did our team charter, discussed what we wanted to be in our MVP, which is the minimum viable product for any of the audience. Also our MVP 2.0 features, just more features we'd want to add and getting the wireframes done, like the basic layout of the app.
Yeah, so we set up our team charter, we set up our team goals, which was mainly to have fun with the project, embrace the process and develop an app we're proud of. We set up our operations, this included our daily stand-up and retro we had every day, and set up the ground rules for our code review processes, which was kind of like review and approval for 2 team members. We also shared our individual goals for the project.
Before we started the project, we designed our MVP interaction diagram. And what we wanted to achieve on the MVP level was a user would be able to create an account and would be able to have the account successfully stored in our database. And on successful login, the user will be redirected to our dashboard, where the user can then start to use the technologies that we've put into the project to manage their energy levels. So the app would have 2 buttons, which would allow the user log activities that either boost their energy or drain their energy. And then there's a gauge that will display the energy accordingly. And the user would also be able to reset their energy to a neutral level on a daily basis. What we wanted to do was to really get that to reset automatically. But for MVP level, we just put a reset button that allows the user reset their energy level. And also the user would be able to log out of their account.
So for our tech stack, we use Mern, which is MongoDB for the database, Express and Node for the backend, and React front end. We did this for a few reasons, which one of them is that it's a very fast tech stack, it's high performance, and the developer experience is really quite good, especially with React. So it just made it nicer. We used SonarQube for static testing and test coverage. And we used bytest and jest to write our tests.
So we thought it was a really good idea to set up our backend structure, especially because some of us were working on the front end and they would need to interact with the backend. So in the backend, we set up our database layouts for which we used MongoDB. And we also set up the API endpoints to undo CRUD operations and interact with our database. And this would ensure that users can be successfully created, retrieved, and their data updated in the database.
We were one of the lucky teams to have quality engineers in our team. So this meant that quality was kind of at the forefront of our project. We had regular meetings and PR reviews that kind of divided up the responsibility, which ensured we did not compromise on our quality over kind of quantity. Next slide, please. So we came up, well, the quality engineers came up and implemented an Istanbul coverage technology. And this tool represented all our kind of test coverage and assisted us in making sure our unit tests were in line with our expected quality.
What were our problems and what went well? For problems, balancing the development of new features and the testing requirements was a bit challenging, just because for one, one little component you're writing, you have so many tests, which is they're always sad to write. But time, definitely, I think once you add up all the time you spend in kind of meetings or like the kickoff days and everything, although it's 2 weeks, it's not like that long. And also resources in terms of because we had the 2 QEs, which were very grateful for. They were very lovely. We had 2 less developers as well. But what went well was that we communicated well. We all got on really well, which just, it's nice being in a team where you don't hate each other. And yeah, we just worked well as a team, had problems, and we solved them. And here is our demo video.
And let's click play, Reese.
Pardon? Oh, is this not coming up for you guys?
I can't
So
hear
we
it.
can't hear the audio.
Oh, my bad. Let me sort that quick.
Hi, everyone, and welcome to the demo of the Neurons. So this would be the typical landing page where a user will be directed to when this app is visited. And depending on whether the user is already an existing user, they can log in straight away, or they join the Neurons link to set up an account. And the way this sign up page has been designed is that all the fields need to be properly filled for the information to be successfully stored on the database. So if a user were to try to just fill in, let's say, just their first name, it would not allow a user sign up, and it would give you a specific error message telling you what field needs to be completed. And this would do that for every field. So please enter an email. It would also specify the expected pattern for the password. And upon successful login, a user will be redirected to, successful sign up, a user will be redirected to the login page where they can then log into their accounts. When a user successfully logs in, they are navigated to the dashboard where they can then start to use the energy tracker to manage their daily emotional and cognitive energy levels. So typically, there are 2 buttons here, and one of the button with the green one would be meant for adding activities that boost energy, and the red one would be meant for adding activities that drain their energy. So I'm just going to try to add an activity that boosts my energy, and I would say coding. And I would say that boosts my energy by 5. And once this is submitted, the gauge is then accordingly adjusted from a neutral energy level to a +5. And that activity is logged onto their list of activities. And in the same way, if I were to add an activity that drains my energy and give it like a energy drain of -10, the gauge will be adjusted to to reflect their energy loss as well. And a user will be able to reset their energy levels to a neutral level, which ideally for MVP level, it was meant to be like a reset button, but the vision for this is really to have it reset automatically on a daily basis. And yeah, that's it. And once they log out, they're taken back to the login page, the landing page. Thank you.
Oh, thank you, Neurons. Excuse me. Perfect. Thank you, Neurons. Yeah, I feel like you guys have attempted to solve like a really important problem. And yeah, I really enjoyed working with you guys over the course of the last few weeks. It's nice to see how things have come together. And yeah, also you were there he is, the only team that designed a mascot. So I think bonus points for that. I wanted to ask one question because, excuse me, I'm losing my voice. I really liked how you guys worked together. And I wanted to ask which part of the agile process that you did do you think helped your team the most and why?
I think I would say it's just keeping track of our using the Trello board to really keep track of our tickets and getting those tickets assigned, making sure that a member of the team was responsible for making sure that those tickets were being completed and making sure that our tickets were split into different sprints so we know which tickets were getting rolled out at that moment. So that was really good for organizing our project.
Amazing. Thank you, Shay. Does anyone else have any questions? Or Tom, did you want to say something? I think you put your hand up. No? Okay.
Tom, you're on mute. Sorry, I'm on mute. That's a good test for later. No, just to add that I think the fact that we made sure that we held both stand-up and retro every day without fail really made sure that we kept that level of communication. And if we did come across blocks, these things were flagged early and we were able to resolve them quickly and efficiently. So that was cool.
Amazing, yeah. And I'll reiterate, I think what Reece said in the demo as well. Yeah, you guys had a great team dynamic, so amazing. All right, thank you, Neurons. Next up, we have the book club.
Okay, so can everyone see my screen? You can see the start of the presentation? Yep, okay, fab, cool. Okay, just gonna move the meeting for myself. Okay, so welcome to Owlet Story Time. Owlet Story Time connects distant relatives with their family by providing a fun, beautiful platform to pre-record bedtime stories for children to listen to. So parents and children can pick stories that they would like to hear, and the children can pick who they would like to have read the story to them. So this was inspired by an auntie who wanted to connect with her niece who lived far away. I am that auntie. My niece lives 9 hours away. She's a lovely reading her stories, and I was quite good at it, doing sort of silly voices and stuff like that. So the idea with this was that it would open it up to a much wider community, and as I think we will kind of feel connection and community are lovely cushions to have in life, and just make life a little bit nicer. So we'll go on to talk about our build.
So we started with a really great idea, but an otherwise blank page. Over the next 2 days, we planned and mapped out our user stories for our parents, readers, and children. We then broke those down into smaller features and tasks. We prioritized these and pulled out what we felt was the most minimal viable product we could envisage. And finally, we diagrammed everything: the page map, the front and back end connections, the relational database model, and the routes we would need to build this MVP. And on day 3, we started to build. We had decided to work with Python, PostgreSQL, and Flask in the backend, and use JavaScript and React in the front end, as we wanted to cement our knowledge of these tools from earlier in the projects and use SQL for our relational database and have a really reactive front end. We had a deadline for end of day Wednesday for our skeleton MVP, and while it was a skeleton, by the end of the day we had a thing which was recognisably an app. Next sprint, we focused on the things which were necessary but hadn't quite made it into that MVP: Cloudinary and a lot more of the data model. The final sprint focused on more user-friendly features, such as security and styling. Throughout all these sprints, we kept strictly to meeting every morning and afternoon to prioritise the tasks, ensure everybody knew what they were working on, share success, and have space for emotional check-ins. And we worked with our 2 QA engineers to do regular code reviews and merges to enable us to identify any bugs quickly and keep our code as clean as possible.
One of the things that we are very proud of is the level of planning we did. We spent a lot of time on it. And at first, we were scared that we were spending a bit too much time and not actually working on the project itself. But it turns out that when you do that level of planning, it really does help streamline the process. And it got us all on the same page and allowed us to have something to refer back to when we were working on our own tasks. Another highlight would be the wonderful team I worked with. Everyone was always available to help out, whether it was with the project or emotionally. And these two things allowed us to build a platform to let us do what we really enjoyed, which was problem solving. Now, there were a lot of frustrating moments where we couldn't figure out where the issues were. But the greater the obstacle, the more satisfying it was to actually overcome it. And this allowed us to build something that we are very proud of. And here is a demo of that.
To Owlet Story Time, our app, we're going to start off by signing up. So you have to enter an email, username, and a password. And as you can see, there's plenty of security requirements on the password. Once you've met all those, you'll then be a user and you can use those credentials to log in. So we're logged in as Amy, but we're also logged in as Montoya so that we can demonstrate connections. And what we're going to do is head to the Family Hub. And we're going to make a connection request to Amy. And as you can see, that's now pending in your connections. Over in Amy's account, we can see via notifications that Amy's received a connection request from Montoya. So she can clear those and then head to her connections to approve that connection and update the status of it. Back in Montoya's account, Montoya will be able to see that Amy has now gone from pending to approved. So in Montoya's account, she can then make a story request. So we're going to make a request for a story about silly frogs. And we're going to request that Amy is our reader, and we'll send that. So we've now sent a successful story request to Amy, asking for a story of our chosen topic. And Amy can then see that request come through in her account. So at the moment the status is pending, she can choose to accept or reject it. She's chosen to accept, so she can then head to her stories and record a new story. So in here, if you press on the microphone button, we can start recording. I'm a silly frog. This is a story about me. We can save that, give it a title, and then select who we want to send it to and send that story back. So over in Montoya's account, you can see that there is a story request that's been accepted, and in the stories page, Montoya can see that that story has been sent to her. She can listen to it and then she can approve or reject it and update the status. And then because it's been approved, this means she could then head into child mode. And it's at this point where she would give this app to her child, and the child would then be able to listen to the story through the Your Stories. There's only a couple of things that you can do in child mode in order to keep it nice and safe. One is that you can listen to stories that have been approved by your parent, and you can request a story and see previous story requests. You can only make requests to pre-approved connections. And so you can see Remy and Amy are approved. And that is pretty much it. Hope you enjoyed the demonstration of our app.
So that's where we're currently at, but we're really excited by all the ways we can continue to develop and scale the app. We're currently focused on 5 key areas. The first, connection and communication, so being able to create multiple child profiles in the Family Hub or send email notifications with different status updates. We'd love to be able to filter by content. That might be by relative, by age, by genre, by reading level. So lots of opportunities to filter the content. We want to enhance interactivity for the child, so being able to like or favorite different stories, create playlists of their favorites, send hugs to a relative. We've got ideas for further engagement, I guess on a smaller scale, things like just adding a profile picture, but we've also thought about engagement levels for children and adults. I guess, for example, a child, when they first start using the app, they might be classed as a snowy owl, but the more they engage, the more stories they request and listen to, they might go up levels to a wise owl or something like this. And the final area, and probably the most important, is about broader accessibility. I think this is such a needed app, and it's considering children who don't have access to people to read them stories, or they might not have access to books and things like this. And there's also people who might want to contribute, reading stories to children that have this sort of need, rather than just reading stories to relatives and connections and things like this. So there are 5 areas we're really keen to pursue further. So that's all from us. Thank you so much for your time. We hope you enjoyed hearing it as much as we enjoyed sort of building it, and we'd love to open it up to questions.
Amazing. Thank you, Courtney, and thank you, team. Yeah, I really love this app. I think Andy said it, and I really agree. It's a fantastic concept and really unique idea. I don't know how it doesn't exist already. And yeah, it's been amazing to see you guys pull together and build it. It is a fairly complex app, I'll say. Duolingo's nice cousin. Yeah, we love that. Amazing. I'm gonna ask you the same question I asked the first team. What are you guys most proud of about building your app?
I can speak to that. I think there's a few things. I think that the impact that it could have is certainly a big sort of area, and something that we were all really aligned on. I think the working practices that we sort of implemented really, really helped us as a team. I know sort of Mustafa mentioned planning, but we spent 2 solid days sort of planning this out, but it just meant like once we started actually building and working on it, we could all just refer back and we understood exactly, what the data structure was, what the different routes were, exactly what sort of third-party cloud service we were going to so we really, sorry, there's an echo. So yeah, planning and sort of those processes, the stand-ups, communication, constantly checking in with each other. I think that all really helped. I don't know if anyone else on the team wants to add to that.
Yeah, I think the impact is is my kind of favorite thing about it, is that it could be something really, really lovely for community and connection. That's something I'm really proud of.
Amazing. Yeah, Hannah's asking when are you shipping, so I think that really says it all. Cool. Is there any other questions?
Has Tom got his hand up?
Yeah.
Perfect.
Tom, you're on mute if you're trying to talk to us.
I've really got to get a hang of this mute thing. As the other team who had the quality engineers built within your team, how did you find that process and having those 2 as part of your team?
Should I answer that? Yeah, it was really great. I think it was really I don't know, it was really nice to have someone looking at our code and having that kind of knowledge that someone was going to be looking at our code from a quality assurance perspective. We had a very funny conversation, me and Rosie, when we were pairing really early on. We're like doing something like, oh, that's not very tidy. Oh, the QAs are going to look at that. So it's actually that kind of constant reminder of like, oh, actually someone will be looking at this. But also they had so many different tools that they could use to, send 1,000 passwords at our password generator tool and check which things might have fallen through the cracks, and that was just really helpful. So I think it was really great just to learn to work with them with that, and kind of and also all the different tools that they were going to be using.
Brilliant. Thank you, Amy. If there's no other questions, we can move on to the next team. That's one more question.
I've got a question, if I may.
Sure.
Thanks for that. That was really impressive. I had a question about, you kind of downplayed it, but it seemed really impressive that you had 2 layers of authentication in the app throughout. Could you speak about how you made the parent and the child levels?
Yeah,
and
definitely.
kind of, I guess, what your philosophy was with that, maybe.
Yeah, obviously it was really important because we wanted to create a safe space so parents could really confidently, put the app into child mode, give it to their child, and they're not going to be able to do anything that they shouldn't be able to, just make random connections and improve them with different people and things like this. So what we did was we sort of set up permissions, so created tables with roles and actions, and then we mapped that role within a user's table. So actually, when they put it into child mode, it could only access routes and actions that were associated with a child permission. So once they were in there, they could only do those actions, but actually we also set up within the route so that if they were a bit more clever and they tried to sort of click back on the screen or something like this to navigate to different web pages, it was just unauthorized. So they couldn't actually access anything in the app outside of the activities that we set out that they could.
Amazing. Yeah, great question. I agree. There's a lot going on behind the scenes to make all that work. Cool. All right. So we finally have Team Terra.
All right, let me know when you can see my screen.
Yep, all good.
Brilliant. Also, just wanted to start off by saying there have been some amazing demos so far, and I think we should all be super, super proud of everything we've done over the past 2 weeks. There's been some amazing stuff on show today. But anyway, we are Terra. So our team consists of Danny, Ledia, and myself. During this presentation, we're just going to briefly introduce who we are and what our product is. Then we're going to talk a little bit through what our process was, including how we got to our MVP, how we progressed from our MVP. Then we're going to jump into the good stuff, which is the demo, and then we're just going to conclude with some of our successes. But first, just to talk a little bit about who we are. So a couple of weeks ago, we realized that we had a common interest in air pollution data. So we really enjoyed kind of checking the stats every single day to find out where air pollution was highest and lowest. But what we also discovered was that generally the places that we were getting this data from was a little bit ugly, a little bit confusing, and just generally quite overwhelming. So we decided that we wanted our mission statement to be to make air pollution data accessible, digestible, and engaging. In order to do that, we identified there were kind of 2 key questions that we needed to address to build our product. The first was, how do we get that air pollution data? And then the second was, how do we show that data? And answering that question became the basis of our MVP.
So the goal that we had for an MVP was to basically just be able to make an API call and print the data on the screen. Pretty simple, but it had its own issues. So the first thing that we did was we chose an API. Oh, well, we decided to work on this MVP through map coding, considering the size of our team and the fact that we needed this to, work. So yeah, we looked at different options and we decided upon open weather because of the amount of data that it had. It had historical data and its opportunities for scalability. So through a bunch of trial and error and stuff, we managed to fetch the data. And we actually had issues considering that we ran out of API calls immediately while we were working on the MVP. Just through refreshing and trying to debug, we made 1 million API calls, a lot more than we were expecting, and we were locked out. So we knew that we had to figure out a work around that, so we were able to actually show all of the data that we wanted to show. And after we managed to fetch the data, we managed to parse it more or less, because the issue with open weather was that it gave us the data according to the latitude and longitude, not through the name of the country or the city. So we had to do a bunch of data wrangling to be able to translate what we got from the API into information that could be digestible, not just for us and for a user, but also to the technologies that we were using to make the website. So yeah, we managed to print out the data as we wanted. We felt like kings of the world. It was pretty great. However, the next question was, how do we show the data, considering that, as you saw on the previous screen, it looked horrible and it was almost impossible to understand. So this next question was what informed our subsequent versions.
Yeah, so following on from our MVP, we decided on our version 2, and this is all about gathering data. So from our initial API call, we then scaled up to 20 API calls and displayed that in a very simple table on the front end. For version 3, this is all about displaying the data. So here is where we introduced Apex charts and React Simple Maps. We also managed to reach our stretch goal of doing 200 API calls for countries around the world. Version 4 was all about styling. So here we gave each air quality component a different color and rendered that in both the chart and the map. We also introduced an automatic API call in this version. And in version 5 was just about code cleanup and just bug fixing. And that leads us into our demo.
Hi, this is Terra. I'm going to show you around our website a little bit. So this is our main page. This is our landing page. You can see our logo at the top here. You can also learn a little bit more about us if you click on this About Us button on the right. So we've got a little bit of an info about who we are, what we do, and some of the highlights with our project. Then the main part of the landing page is this heat mapped world map here. So what it's showing us is the AQI data for the 30th of April for each of the countries in the world. AQI stands for Air Quality Index, but if you were a little bit confused about what that meant, you can go down here to this dynamic sentence that repopulates, obviously every day, and learn a little bit more about what the Air Quality Index means by hovering over this information button here. You can also get slightly more granular data if you hover over each country. So say, for example, here we can see that the AQI, the Air Quality Index on the 30th of April, was 2. And then you can also go to this little button up here and you can toggle so that it shows you different data. So for example, I could go find out what the O3, which stands for ozone, concentration was for the 30th of April instead of the AQI. And what you'll see is that the map repopulates itself and shuffles around the colors according to the O3 index for that day. But you'll also see that the data that appears when we hover is also updated too. If I now scroll down, I can show you the second big component of our homepage, which is our heat map.
We don't say what SSH is.
Oh, sorry. I'll keep going. Which sits at the bottom of our page, which shows all of the data for all of the countries that we have data for. So if you wanted to find out a little bit more about what the trends look like for the past 30 days, you could scroll down to our chart below and find that out. And it's visualized pretty clearly with obviously the darker colors being a higher concentration for that day. And you can see here all of the countries that we've gathered data for. If you then wanted to get an idea of what this trend is like, but for a specific country instead, what you can do is scroll back up to the top and select the countries that you want to see the data for. So for example, if I click on Russia, which seems to have a fairly high O3 concentration, you'll then be able to see that plotted out on an area chart instead of that heat map from earlier, which just makes it a little bit clearer. You can get slightly more granular data. And what you can do as well is hover over all of the data so that you can get the specific numbers for each day. If I then click Russia again, it will then just reset the chart again. And I can go through each of these indexes and you'll see that the colors change according to what element I'm interested in viewing, and those are matched down in the chart below. To show you around a little bit more of the data. And the way that this data is collected is we do have a back-end database which stores the bulk of our data. And then every time the website is refreshed, we run a check to see whether or not that data needs to be updated. So if, for example, the last time the website was refreshed was 3 or 4 days ago, our back end would know that it needs to update for the last 3 or 4 days. It would run that and then obviously show that data to the user. And as those numbers get updated, as these cities kind of move into the new time zones, that will be automatically updated. And that's our website.
And on to our successes. So I think we were very realistic to begin with. Being in a team of 3, we had a really scaled back version of our MVP, but I believe that allowed us to have sort of it might have been a slightly small app, but it was very high quality end products, which we're really proud of. Like I said, being in a small team, it really allowed us to feel very rewarded because we had a part to play in every single aspect of the project.
I think we were also quite resourceful because we didn't try to code the map and chart from scratch. We were quite happy looking online to see what other solutions that people had already created and shared with the world, and we just adapted them to our needs and wants. And the fact that we implemented a backend and a database there meant that we were able to make it quite scalable. So we, instead of making 200 API calls per day just whenever anyone refreshed the website, which wouldn't really work for a free trial for an API service, we saved it to the database and just refreshed the extra data that we were needing for the next day. So that made it quite scalable in a very small budget.
We were also able to pivot very quickly. So for example, we started off with our app having a backend, then we got rid of it, then we decided that we actually did need a backend, and so we had to build it all over again. But we never really let us phase us. We were always kind of moving on, and we always kept moving at an agile pace. And then finally, data handling. So Danny alluded to this earlier, but we are obviously handling a lot of data, both in the back end with the API calls, but also in the front end. We have lots of dictionaries that enable us to parse the data and display it in a way that's comprehensible. And also we have things like scripts in the front end that are generating JSON data that we can test with as well. And we think that we're handling that very efficiently and succinctly. And that's the end of the presentation. So thanks so much for listening. And yeah, we welcome any questions.
Amazing. Thank you, Team Terra. I love the app. I think it's been said, it's very nice to look at, and it's the app it's another app I wish I had. You're also the smallest team of 3, and again, yeah, working with you guys, always being able to be very agile, pivot, and like work on things in a very like agile way, I thought was really impressive all the way throughout. And actually, that's my question, was I wanted to ask about your experience working as a 3, and how did you guys, because you were so tight knit, how did you guys evolve the way in which that you collaborated as you learned more about working together over those over the 2 weeks?
Yeah, I think we found it quite daunting at first. We realized it was just the 3 of us. I think I sent a Slack message to the channel being like, is anyone else joining us? But no, it's just the 3 of us. But I think as Ledia alluded to, it's definitely, I think we worked it into a blessing. I think we were able to, I mean, obviously we mob coded like the first version, which was where we were just trying to get that API data. So we all had a really good understanding of like the kind of basic skeleton of the app. But then at that point, when we were all kind of comfortable, we'd achieved our MVP, that's when we kind of split off. And I think that's when we really were able to achieve a lot. I think our version 3, where we went from having like basically just a black and white table on the screen to suddenly having like an interactive world map and an interactive chart at the bottom, was like huge. And I think we did it relatively quickly. And I think that's just a testament to like how well we all understood the app, but also how well we all kind of worked together as well.
Amazing. Yeah, I love how you said you turned it into a blessing, because I definitely felt that. Danny, did you want to say something?
Oh no, just that it was being a small team helped us be quite agile. Like we were able to pivot quite quickly instead of having to make sure that everyone was on the same page. And I think because of that, everyone has an understanding of basically every single bit of the app, because even when we split up, we still got together, asked questions, helped each other, tested together, complained about testing together and everything.
Amazing. Thank you. Any other questions? Reese?
So first of all, the fact that you guys did that with 3 people, just again, well done. That's incredible. And I wanted to ask, for your components, did you use a component library at all, or yeah, like how did you guys go about that?
Yeah, both the map, it was from Apex Simple React Simple maps, and the chart is Apex charts, and they were both 2 component libraries, and we adapted them to our needs. But yeah, like we got them off of line. Like the tooltip, for example, was something that we needed to make ourselves to make sure that it showed the right data, especially when you toggle to different types of molecules. But otherwise, yeah, we just got it from the internet and checked the documentation and prayed that it worked.
Yeah, there's a lot of documentation.
So much documentation.
A lot of reading.
Well done, guys. You've done amazing.
Thank you.
Thank you.
Cool. Any final questions? if not, I think I can pass it on to either Neil or Sean. But yeah, I'll quickly say I think you should all be very proud of yourselves. And we always say 2 weeks, but really you start coding on the Wednesday and there's a feature freeze on the Wednesday, the Wednesday of the next week. So this is like 6 days worth of coding, which is like really impressive. And yeah, yeah, you should be very proud of yourselves. Cool. I think Neil, you're up.
Yeah, I think coming straight to me, Steve. Thank you very much. Thanks, everybody. Thank you to all 4 teams, all of whom I've been working with during the past couple of weeks in various capacities with different hats on. And it's really great to see what you've been building. We're going to fixate now on just those 2 teams who had quality engineers within them. And I'll tell you a little bit specifically about what they've been doing. Over the next 20 minutes, you'll see 2 presentations telling the stories of some projects you've already seen, but from a different point of view. So the quality engineers have been working with us for the past couple of months to learn things such as how and why you write test automation, how to support that with structured exploratory testing, how to perform other kinds of non-functional testing like accessibility, performance, security testing, and how to use a whole host of different tools and techniques to help to discover important issues in their products. And then they've finished up with their final challenge here, which is my favorite part of the course. It's like the best thing I think ever in the world, which is they get to cut their teeth on a real project. And so they're not just landing into the wild in their workplaces next week or beyond, going, what's it like to work in a team? They've got to really experience that. If you were to rewind this video later and watch back, if you've just joined us now, you'll see some videos of those apps in action. But we're going to speak to the 2 teams now and hear the story of how those projects were built with quality in mind. And we're going to start with Owlet Story Time. This was a pitch that really struck very close home to me. It took me back to when I was sort of 8 or 9. And whenever my grandfather would babysit for me, I would ring him up on the phone in the mid-afternoon and tell him what story I wanted, which of my teddy bears had to feature in it, where it was going to be. And I love the fact that this is now something that you can just put in the cloud and it spans boundaries. Let's hand over to Amir and Nadia to find out how you test an application like that. Over to you.
Okay, so first of all, can you see my screen and hear me clearly? Awesome. So if you've never read a story to a child, you are missing out. And it would be even better if you used our app, Owlet Story Time, as kindly introduced by Neil just a minute ago. And you saw the demo of it from our amazing developers just a little while ago. So now I, Amir, and Nadia will be telling you our story from the quality engineering perspective. We had a number of objectives initially. We wanted to embed quality into this product throughout the software lifecycle. So usually people think of quality in terms of testing, but we went way beyond that, as you will see. We had to work with a team of developers. We'd never met them before. We'd never even seen them before. So right from the start, we had to make sure that in terms of our differing responsibilities, we dealt with each other sensitively, we maintained our boundaries, and we gave feedback that was collaborative. As you know, within 3 days, we had this minimal viable product to build. So it was a very tight schedule. And one of the challenges also is to be building trust while we were building the MVP. The first stage of this was requirements, which Nadia will tell you more about.
Thanks, Amir, and hello, everyone. Can you hear me? Thank you. So we spent our first day, first of all, as Amir said, getting to know our devs, our amazing devs. It was very important to us to build rapport as well as a product. And on the left here, you can see a diagram that as a team, we were working on designing our MVP in categories of must-have, should-haves, could-haves, will not have, or for future development. So that, as you see, was quite a lot. So let's see what we did as quality engineers to support our developers. So next slide, please, Amir. So in order to support our devs, myself and Amir contributed as QAs. Apart from collaborating, of course, in the ideation of the project, we analyze requirements for ambiguities that could cause later problems. And as you can see on the left, we produce a dev-friendly feedback based on the previous diagram.
The next thing we looked at is documentation, because when you land on our project on GitHub, the first impression that you might get is from the README file. It needs to be really clear and accurate so that people can install our app. And we definitely consider this part of the quality of the product. So how did we contribute? Well, we quality checked our developers' first draft of the installation guide. We did find some ambiguities and areas of improvement. So we gave some feedback, including a suggested second draft, which we thoroughly tested ourselves on a number of devices. And then after we'd run this past the developers, we came to an agreement that it was worth pushing those changes back onto GitHub. On the left, you're seeing the kind of thing that we produced. So we've got all of our dependencies clearly stated. We've got the instructions, very, very easy cut and paste type instructions so that people can successfully install our app. Also, as the project went along and we were producing more documentation, wanting to communicate it with our developers, we made sure that we logged it all, explained it all in a very easy to access reference document that other people who look on our GitHub and want to see what the quality engineers were doing can also access.
So in terms of implementation and code reviews, well, as a team, we decided that every time we would push new code or documentation onto GitHub, we would need 2 reviewers, and that would be 1 quality engineer and 1 developer. We think that that was a very, very good thing to do because we gave feedback on code readability, structure, layout, and tests. It's very important to mention that our devs were amazing, lovely. They took on board our feedback, and we believe that altogether we worked on producing very, very high quality code, and we're very proud of that. And just on the left, you can see a little comment of mine when a pull request was pulled on GitHub. And yeah, so this is how we communicated and worked for code reviews.
So the next thing we did was manual exploratory testing. And in this, what the quality engineers do is they will run the app and then basically we prod it and poke it and try to break it, not to annoy our developers, but so that if there is a bug, we find it and not a parent or a child who wants to use this app. So initially this was quite challenging. We tried to start as early as possible because we were in mid-development. The styling was still to come. On the left, you can see some examples of the kind of freeform notes that we were making as we were exploring, just to see what happened when we tried interesting things in the application. Now, it turns out that from this process, we did find a really important bug. Now, if you recall, this app is centered around children, and child protection issues are one of the really fundamental non-functional requirements. And we wanted to make absolutely sure that the children or other people could not get unauthorized access to pages that they shouldn't be seeing. And we found a bug related to this. So we communicated that through to our developers using GitHub issues.
So accessibility testing, well, I have to say that me and Amir loved learning about accessibility testing during our course. We believe that accessibility testing is very, very important. Testing a website and app content is crucial to ensure that all users, regardless of disabilities, can access and interact with the content effectively, promoting inclusivity and compliance with legal standards. That is very, very important. So this was one of our priorities. We wanted to see if our app could, for example, support someone who is visually impaired. And we used 2 tools. One of them was VoiceOver, which we won't go into too much detail right now, just for time purposes. But on the next slide, I will show you Colorblindly, which is a tool that we can use for people who are visually impaired. So we can see on the left, this is the lovely login page that our devs built with the colors that they chose. And then on the right hand, maybe you can see a bit of a different shades in the color, and that is because we use Colorblindly, and this shows us that our app actually works with Colorblindly, that we can change the shades and we can make our app inclusive, and we are very, very proud of that.
Okay, so the next thing that we worked on was automation, which is very highly respected in the industry. And we did this from two angles. One was that we automatically generated test data. So we wrote in JavaScript using the Jest test framework, randomly generated passwords that we could look at the validity of using the code that our developers had produced. And we ran 1 million tests on that. On the left here, you can see some of the output from our code. So it's telling us what it tried and whether or not it was valid or invalid. This gave us important feedback, and we found some bugs that our developers kindly improved the product with. The other technique that we used is called end-to-end testing. Now, with end-to-end testing, we write code that will automatically start up the app, and it will simulate pressing buttons on the app, typing things in, and moving around from page to page, and so on. Now, you remember that bug that we found previously, the authorization bug? Well, we wrote automation code to specifically try to target the existence of that bug. So we could very quickly check, does it still exist? Have any of the changes introduced it, reintroduced it? Again, they're called regressions. And how did that all work out? So Nadia's going to tell you a little bit more about that.
Thanks, Amir. So here we can see on the left top, we have our tests that we use Java and Selenium. And at the bottom, we can see that the test is not passing that. Now, as soon as we tested this, myself and Amir took this very seriously, and we spoke to our developers. And on the right side, you can see that there is a green tick, and the test did pass after our developers actually fixed the bug. And it was a very, very important moment for our product and the quality and the safety of our app. And finally, conclusion. First of all, we had great fun. It was lovely working with our developers, getting to know them, and I believe for the amount of time that we had spending together, we worked really, really well. Obviously, there are always areas of improvement, but I believe we communicated very effectively through daily stand-ups, retros, how we had daily emotional check-ins, and that was very important. Myself and Amir believe that we applied loads from what we learned from this course, but obviously if we had more time, we would have loved to use more tech stack and tools for testing, but we believe we will have the chance to do this with this app because we are planning to carry on working together on this app. So that's it from us. Thank you very much for watching our presentation.
Awesome. Thank you both for that presentation. I was going to ask you some questions around securing the application, and particularly with there being parents and children, but Hannah sniped that question from me earlier, so I'm not going to ask that particular question right now. I'm really impressed by the way that you've done a load of things that to you seemed just like common sense, but that in the outside world, like there isn't as much uptake on things like that. Like the idea that a QE will take a look at a pull request as a way of helping to test and improve the quality, it's particularly when it's in a language that you've not necessarily coded in yourself. Like just to roll up your sleeves and to go, I'd like to get involved in this level. I'd like to see how early I can contribute. It's really really impressive. We've got time for, did I see a question in the chat somewhere? Something flew in front of my eyes. Let's have a look. There's a question in the chat for, oh, okay. Andy has asked, will we have access to the recording? Yes, this will go up on the Makers YouTube channel at some point to be determined in the future. The links will arrive with you somehow through the ether. It will happen. That link will happen. Do you have any questions from the floor? Did I see a hand somewhere? Maybe not. I will say, like the screenshot you took of when your randomly generated passwords, again, a really good way of doing automation. People think of automation as just being those tests that have a pass or fail, but the idea that you can use code to augment your testing, that then led to a conversation within your team. I watched it happen where you said, well, we're using these symbols in our passwords and the validation says these symbols aren't valid. Is there something special about these symbols? This feels like it should be valid. Like just generating information to help your team. Really impressive, both of you. Thank you very much. We're going to move on to the second team, which is the Neurons. They were the other team who had testers embedded in them. I was introduced at Makers a couple of years back to the concept of spoon theory, a way of tracking your energy through the metaphor of spoons and having enough spoons. I always then had this side effect of, to me, it seems like it would take one of my spoons to measure my spoons. So the idea of having an app that takes care of that for you is amazing. And I know this is an idea that was close to the heart of everyone in the team. So I'm going to hand over to Tom and Daisy to tell us the story of how they tested the Neurons project.
Hello, everyone. Can everyone see my screen?
All good.
Cool. So yeah, we are the Neurons, and then here is how we work as quality engineers in this app. Tang and I are quality engineers who work with a fantastic dev team, Therese, Shay, Farad, and Jack.
So as the guys covered off earlier in their dev presentation, which was brilliant, the app is to support neurodivergent people in tracking their cognitive and emotional energy levels. So the key features, just to kind of recap them, were to create an account and log in, add activities to the dashboard that will either plus or minus energy score, and give a visualization of that for people to be able to keep a track of it. So with our devs, we were fortunate enough to be able to get involved from day one. And as they showed in their presentation earlier, they did a lot of work around ideation, the tech stack, technology that they were going to use and how they were going to deploy the app. This actually provided us with a great opportunity even from day one to start thinking of scenarios and potential test cases that we would want to run as the app got developed. So before even a line of code was written, Daisy and I were in a position where we were able to start to develop these ideas, which put us in a great place from a quality perspective.
Cool. So we focusing on the accessibility because as the previous QE team mentioned, we want to make sure every user is inclusive. And then also we focusing on unit tests and coverage, and also the effective bug reporting to show the dev team what's the problem, and then let them able to fix the issues. And last but not least is the deploying the right tools at the right time. So for example, the static analysis, and then also exploratory testing and the automatic checking. And then we will show more details when we go on.
So as Neil touched on, in 6 weeks, we covered a whole load of different tools and techniques that we can deploy from a quality perspective. And basically, here's a list of the ones that we used. Two to kind of focus on really were Silk Tide, which we use from an accessibility perspective that Daisy will cover off in more detail later, and Sonar Cube that we built into our CI pipeline through GitHub Actions from the early stages to help with static analysis of code, which I think gave our devs some really useful insight into the quality of the code that they were writing.
So the procedures to ensure the quality, like our dev team mentioned previously, we have team charter from the day one. So we are able to set up our regular meeting, for example, at 10 a.m. for stand up, retro for 4:30 every day. And then also we set up the GitHub branch rules, make sure not there is no one accidentally push or merge to our main branch. And also the PR review process, at least one QE perspective, and then also one dev team from someone apart from the code who submit the code. And last but not least is the GitHub issues. So as we mentioned, we use this as a bug reporting and also tracking.
Yeah, so as we also focus on unit testing and coverage, we really wanted to try and push as much of the testing left as possible, which probably sounds a bit mean, like dumping all the testing onto the devs, but actually it's proven that if you can get right levels of unit tests in place and the correct kind of coverage, and the right kind of tests, you can avoid a lot of bugs later down the track that actually can be quite extensive to fix and hard to debug. And I think our devs really bought into this. We used the frameworks that they decided to use for the unit test, but then deployed the coverage frameworks that they had that allowed us to really get an accurate view of what that looked like. And within the project scope, there was a target of 90%, and we really did try and target that throughout the project. We also wanted to, get involved from a code quality perspective as early as possible. So we deployed SonarQube as a static testing tool. This really gave us a good reference point from both a QE perspective, but also from a dev perspective, to see where there might be areas of code that could be vulnerable, or where there might be duplication of code. And it kind of removed that discussion over personal style or preferences. And this was based around industry standard and expectations, which again, I think the dev really appreciated that level of feedback, and it really did ensure that the code quality at MVP was of a high standard.
And here is the automation testing video, which show we using Java and Selenium for the end-to-end testing. And then this one is about the sign-in automation test. And the test tool Silk Tide, which Tom mentioned previously. And this one is the very useful tool for the website accessibility, also SEO, and the content quality. So all the function showing on the screenshot, and then also we use it as our color blindness user. So make sure our color works for most of the user.
We were also conscious as a QE team that time was of the essence, and we didn't want to be constantly disturbing our devs who worked in pair programming format often to with, oh, we found this bug, or so we chose to use GitHub issues as a way of communicating these. We set up some specific labels as well, so that we could then show levels of severity, areas within the code that it related to, and then also, so you can see there on the left-hand side, we had a kind of mixture between bugs, security issues, and then just general enhancements that we felt from our exploratory testing would improve the UX if there was the opportunity for that to be addressed.
And the obstacles encountered, I'm going to talk some challenge we face. So first is the CI setup, is stand for continuous integration. So like we showing previously, we successfully implement the SonarQube as a Sonar Cloud to work with GitHub Actions. However, we find some difficulties in getting the unit test and coverage to work on GitHub, but we actually run through locally successful. So we might continue to work on and then solving this in the future interaction. And then secondly is the coverage setup. So at first we find it difficult to set up the coverage tables and then the result, and then we later on find out it's because of the library versions and then package environments. So we refer to the official documentation and also asking our dev team and then also the coaches. So we are able to debugging all the previous issues and successfully show on the data. And then also the time frame. So we only have 2 weeks. Like in reality, is actually just like maybe 7 days for able to work on, but we using our time effectively through effectively communication with the dev team, and then we priority our task, and then also we dynamically adopt the challenge, so the change, so we are able to solve all the problems, and then we are able to show all the result we happy and proud of.
And last but not least, the team successes. I think I was immensely proud to be part of this team. I think the 6 of us all worked incredibly well together as a team. The communication was excellent. Thank you to the 4 devs that we worked with. We genuinely had, they genuinely embraced our contribution and our presence within the team. It could have quite easily been different. It could have been a tug of war, but it wasn't like that at all. And part of that as well was that I think all of us were pragmatic. When there was times when we had to ease off on the testing requirements, we did. But equally, when there was something that we really needed the devs to focus on, they listened and they really responded well. So the whole experience for me was a brilliant one. So yeah, thank you. And from Henry M. Roy, thank you very much.
Thank you.
Is that the name of your mascot?
Henry Roy, MD. He was our managing director.
Fantastic. And thank you very much for Tom and Daisy for your presentation. I got the real sense that this felt like a team project. One of the challenges in the industry is that dev and test can sometimes have this combative relationship of having different goals, different objectives, different needs. But I really got the sense that you were working together as a single team, and you demonstrated some really adept implementation in just what was literally the first 2-week sprint of what would be a much larger project. It was really impressed. A lot of teams in the wild wouldn't have even engaged with testers in the first 2 weeks. They'd be like, there's nothing you can do. But you've got so much in place for the future. And some of that has included independent research. I should say, I'm really impressed by Silktide, not least because we didn't introduce that to you. We talked to you about accessibility and some tooling. You've gone out there and independently found and researched something that was appropriate for your team in the context you're in, which was fantastic to see. I will open the floor for any rando questions or less rando questions. While I wait and see if anything's coming in the chat, let's imagine you have another 2-week sprint now. What do you think would be your focus next? Is there anything you really wanted to get your teeth into that there just wasn't time or you wasn't appropriate in the moment?
I think Daisy and I took a very pragmatic view on test automation and test checking. We tried to deploy it where we could, but the app was developing so fast and changing so quickly. The stability just wasn't there to really have automated checking in place. I think the basis of the app is now there, and Daisy proved that with the Selenium test that she wrote. So I think we would really like to progress that aspect further. Yeah, so
that's the thing. It's all about what's right for the team you're in the context you're in. We can show you so many things over 16 weeks, you won't get to use them all. There is a card that I always thrust up, and when anyone asks any question on the course, I have a card at my fingertips which says it depends. And that's what this has all been about. Like these past 2 weeks for both teams has been, what does my team need right now in this moment? And it's been really clear, both from your attitudes and those that I've heard from the developers in your team, that you've got on really well and really contributed. So thank you very much to both teams. And that is all from QE for today. Thank you very much to everyone for watching and participating. You should all be really proud of what you've accomplished during these 16 weeks. A big virtual round of applause to all of you. And I'm going to hand over now to Leo, who's here to talk to you about the wonderful world of cloud.
Nice. Thanks a lot, Neil. Hopefully you can all hear me. And by the way, I'm going to get one of these it depends card because I think, well, the cloud people will be able to confirm that I've been saying that a lot in the past few weeks. Well, thanks everyone. So we're gonna get to the last section of this demo day today, where the 3 teams who have done the cloud specialism this last 8 weeks are going to present what they've done for their final project. So I'm gonna first say a few words about the group and what they've done, what they've learned, and then I'll let the teams present what they worked on. So they worked on the cloud specialism. So they've learned a lot of different skills than the other specialism, obviously, where software engineers work to design and to build the software, and where quality engineers work to ensure the quality of the software and to make sure it's always at its best and work in collaboration, like we've heard from the 2 previous teams. Cloud or DevOps engineers work in completely different, well, sometimes there's a bit of overlap, but they do bring a lot of new skills and behaviors as well. often people think that DevOps engineers or working in the cloud means, deploying the software, which is true. If software is not deployed, it means that users can't use it, and so it might not be super useful. So there's definitely a part of that, but there's also a whole lot of different things that come to it, especially when you think of the scale of organizations, such as, you can think of Netflix, of Amazon, but it's true even at smaller scale, smaller companies as well. Once the software is deployed, how do you make sure that it stays available? What if there's a failure in the network, or what if there's a breach? There's a lot of things that could go wrong. So you need to think about these things. How do you use cloud providers such as Amazon Web Services, which is, if you've ever touched it, you know that it's quite a beast. There's a lot of things to learn in there. So how do you use that to make your software scalable, resilient, elastic? How do you make it reliable? How do you make sure that the security of the software and of the network is ensured as well? And there's also a lot of other things such as continuous integration. How do you empower software engineers and developers to release efficiently, to release often? And that's only for the sort of like technical hard skills. There's obviously also, like in the other specialism, a lot of what often people call soft skills, which we value as much as makers, such as communicating, giving feedback, hearing each other, working in teams, planning, listening to others and to yourself as well. So that obviously is sort of weaved in, and that's sort of a subset only of what they learned in the last few weeks. It sounds like a lot because it is a lot. So before I'm going to hand over to the first team to present, I just want to, acknowledge the massive work and just the energy and the amount of work that they've done. And so I'm really proud of these 13 learners that are going to present tonight. So kudos to them. I'm not going to say too much about what they worked on. They probably do it better than me. But just to set a bit the context, all the three teams worked from the same premise, essentially. They were given like a piece of infrastructure already deployed, just as if they were to join like an existing team or an existing organization. And they were working with a bit of a clunky, let's say, flaky system that had some problems or some bugs. And the job was to increase what's called the reliability of the system, how to make sure that users can use it and that there's the least failure possible. So there's this idea of increasing quality as well and resilience of the software. And they had a few challenges and annoying constraints to work with, which I'm not going to say too much about. They'll do it themselves better. And yeah, so I'm gonna stop talking now and leave the first team present. So that would be George, Michael, Safaraz, and Joshua. Are you ready to present?
Yep. I believe so.
Okay.
Oh wait, I might have to quit this session to allow screen sharing again. Sorry, give me 1 second.
While we're there, I might ask a question to this team while we're waiting for the slides. How do you feel? How do you feel after these 2 weeks? Do you feel there would be more things that you would have worked on if you had like 1 or 2 weeks more?
Shall I answer that? I would say yes, because AWS is such a huge environment and there's so many resources that you can use. So we only use the basic components of AWS. So I guess we would look into more other resources that we could combine with our infrastructure. So definitely.
Thanks. Anyone else from this team wants to share a bit of feeling on that one as well?
I'm back. That's a really good start.
Oh, that is.
Presentation. It decided to load up in the app version this time, so that's always useful. Sorry, give me 1 second. I'm showing the wrong screen. Okay. Where has it gone? Okay, is this sharing the Google Sheets now? Google screen?
No.
We're staring at your Slack.
Oh my God. Screen. Now?
Yeah.
There we go.
Okay. Sorry, Mac is like totally screwing me right now.
We've all been there. We know it well. We know your pain.
If it was Zoom, we'd be totally chilling. Okay, is that working? Can everyone see?
Yeah.
Looking good.
All good.
Yeah.
Okay. Welcome to Team Blue. Josh, over to you.
Yep. All right. Hello, everyone. Welcome to our final project presentation. This is going to be a quick presentation on what we've been working on the past 2 weeks. We are Team Bloop, made up of myself, George, and Michael, and Safaras, sorry. So just a quick introduction to sort of set the scene. Over the last 2 weeks, we have been tasked with improving and replacing a veterinary hospital's critical system called HOSP. The current system is unreliable, slow, and sometimes goes offline. Our objectives were to preserve and improve the system's functionality, also maintaining over 99% reliability and ensure no security breaches. The trouble is the previous HOSP engineering team have been less than forthcoming, and we do not have access to the front end or back end of the server. All our improvements and work must be done stemming from the load balancer, which will impact many of our decisions we had to make throughout this project. So on this slide, you can see a diagram of their system, which is made up of their end user application, which is mobile devices, computers, and other systems that sends requests. Also their user traffic gateway, which acts as an entry point that manages users' access. Then we have the load balancer, which distributes network traffic from the front end to the back end of the HOSP server. And lastly, their web server, which acts as a computer program that processes requests and delivers requested content to the client web browser. So that brings us on to day one. That's where the team assembled. We got together on a Zoom call, and we first started off by setting up a Trello board, organizing the way we want to work, and looked at tasks we want to complete in the future. We set up a team charter listing things such as our team values, our team goals, communication channels we want to be using throughout the project, and also stand-up times and retro times that we'll be having at the end of the day. So Excalibur was a key tool for us throughout this project. We mainly used it for taking notes, brainstorming, and diagramming throughout the whole time. So this was very useful and was something we used to refer back onto a lot of the time. And that brings us into our first sort of main task, which was gaining access to the HOSP API server. As you can see on the slide is an example of the commands that we used in the command line in order to do this. Next was, after gaining access to the HOSP API server, our next task was to create an S3 bucket. If you don't know what an S3 bucket is, it's a scalable and object storage service provided by AWS for storing and retrieving data. The S3 bucket was created to store access logs. These logs record information about the request sent from the client and to the backend server. And yeah, after day one, that brought us on to day two.
Thanks, Josh. So to analyze the access logs, we used Amazon's Athena, which is an interactive query service that enables us to access logs in a query language like SQL. This enabled us to filter the data using certain parameters, as you can see in the slide. We analyzed the data by writing specific SQL queries to establish which errors were being returned from the host server. We discovered there were a range of different errors, some due to issues on the client machines and some on the host server. As our target was to improve the host service, we placed our focus on the error codes relating to the server. We couldn't find any specific data in the logs to indicate there was a pattern or a particular request that was causing the issues. So we used tools like curl and postman to send direct requests to the host API. Unfortunately, those were unsuccessful and we couldn't reproduce any of the errors. So as the majority of the requests were received by the server were resulted in successful responses, we concluded that we need to approach the problem from a different angle, which led us on to day 3.
So, for day 3, we encountered a common issue where our server was frequently giving an HTTP 500 internal server error. HTTP stands for Hypertext Transfer Protocol, which is a protocol used for communicating between web servers, web browsers and servers. This indicates something was wrong on our side. So our goal was to make our service more reliable by addressing these errors. With the help of our technical instructor, we decided to set up what was called a reverse proxy server. So think of it like as a middleman standing in between the initial request from the user and our main server. The middleman helps by intercepting problems before it reaches the user. We used a tool called Nginx, which acts like this middleman. Its job was to catch any of these 500 errors and keep sending the request back to our host server until everything is corrected and we get a HTTP 200 response, which is like a thumbs up saying everything went smoothly. In an ideal scenario, we would have multiple instances, which are like copies of the host server to handle these failures. However, since we only have access to the load balancer and not the host server itself, using a reverse proxy in this way was the best approach. Just our process of doing this. We started up by setting up a new server using Amazon EC2, which is like a type of virtual server. On this server, we installed Nginx to test. Once Nginx was up and running, we checked the access logs to confirm the traffic was successfully being directed through the proxy to the backend server. After confirming the traffic flow, we moved to implement the redirection logic within Nginx's configuration. Unfortunately, we couldn't get it working. The redirection did not work as expected. So it was the end of the day. We documented it as a blocker, which we plan to revisit the next day.
Yeah, so that led us on to day 4. So on day 4, we began by working as a full team to help improve and reconfigure our Nginx server to ensure our retry function was working as intended. And later on in the day, we also wanted to set up HTTPS for improved security. So after spending some time on our Nginx configuration, we then implemented HTTPS to improve the security versus HTTP. You can see the great AI generated picture of HTTPS versus HTTP. So in comparison, HTTP is more like sending a postcard. So anyone can read what's written on it. And HTTPS is like sending a sealed letter. So only the receiver can read what's inside. So both are getting delivered to their location, but HTTPS adds an extra layer of privacy and security. Unfortunately, later on in the day, we realized that our Nginx config still wasn't working correctly, as our reliability got stuck at around 97%, which was lower than we were expecting it to be. And we were still seeing some of the 500 errors getting through. So on day 5, when the day began, and we had a few different challenges appear on this day. We firstly wanted to fix our Nginx server for like the 4th time. So we worked together to make sure the retry functionality was working correctly. And you can see the kind of corrected version that ended up working on the slide. We then saw some invalid JSON errors appear on the dashboard, which indicated that there were some formatting errors in some of the responses coming from the HOSP server. So we set about investigating the causes of that. And towards the end of the day, we also had a message from the HOSP team saying that an unexpected message had been inserted into one of the vet's notes. And that leads so implementing these things to help with the invalid JSON responses, we found that it could have been due to server overload. One of the ways we found to fix that without having access to the HOSP server directly was to implement caching. Caching is basically temporarily storing data in a fast access location so that it can be accessed quicker next time in case you need it, instead of having to go all the way back to the main slower storage. This helped us in 2 ways. Firstly, it would help reduce the load on the server, which could have been causing the issues. And secondly, it would help to mask the errors by responding with the correct cached response instead of the invalid ones that were coming from the HOSP server. After we added this, we finally reached 100% reliability for a brief time, which felt like a massive achievement after the struggles of the previous few days. And then towards the end of the day, we investigated that note that shouldn't have been there and see how we could fix that issue.
So it was quite alarming to discover someone was able to edit one of the doctor's notes. So we considered some of the ways we could restrict unauthorized access to the service. We investigated the source IP and found that it was a unique IP address, and therefore decided to add additional security by enabling the load balancer to limit access to the server from a specific set of IP addresses from the hospital only. We also enabled the server to return 401 unauthorized responses if a request comes from an unauthorized IP address. We did find that analyzing the access logs through writing SQL queries through Athena was not as efficient as we'd like. So we wanted some monitoring capability. We integrated AWS Lambda and CloudWatch. This enabled us to set some alerts that are triggered by certain anomalies and to trigger scaling in response to possible increased demand in the future. And that led us on to day 7.
So yeah, day 7 was quite eventful. Early in the day, we received a message saying Crufts was being held nearby. A little later on, there was a second message saying the food had been tainted. So we expected an increased number of patients. In anticipation of this traffic, we made a few changes. First, we increased the connection timeout in the Nginx reverse proxy from 1 minute to 3 minutes. And we then created a second larger Nginx instance to run alongside the original one to help handle and distribute the increased traffic. So pre 4 p.m. we were sitting happily at 99.9% reliability until 4 o'clock.
So then at around 4 o'clock, we were monitoring the logs, and we noticed a huge amount of 504 errors appearing in the logs, and our reliability was rapidly dropping to 0. So we found out quickly that the 504 error was due to a connection timeout caused by the traffic increase. So we quickly scrambled to adjust the timeout leniency within Nginx, as well as adding the 504 errors to our retry list. It took a couple of iterations of this to get the leniency as good as we could, but we managed to stabilize the system and prevented the errors from continuing. But it was around kind of 15 to 20 minutes of chaos, and that was kind of the main challenge of the project. To conclude, the final 2 weeks and the whole bootcamp in general have been kind of incredibly challenging, but also really rewarding. As a team, we feel as though we've learned a huge amount. We've worked really well as a team to find solutions to problems. Despite the difficulties and challenges, we had fun and kind of enjoyed the process. We're also looking forward to moving these skills into the real world and continuing to improve and getting stuck in our workplaces. And a final point, we'd like to say a massive thank you to both Leo and Roy for your help and guidance, as well as Will and Hunor and everyone at Makers. And thank you for listening to Team Bloop's presentation. And if there's any questions, then hopefully we can answer.
All right, thanks a lot to you, Tim. Once again, massive congratulations to all your work, not only the last 2 weeks, but just generally from what I've seen, and for your presentation as well. Just for the sake of time, because I think we're running a little late, I'm going to ask if people have any questions for this team to write in the chat, so they can answer in there asynchronously while we move to the second team, if that's all right. All right, that said, let's hear now from the second team to present their cloud project today. So that would be Palash, Dawood, Matti, James, and Lloyd. Are you ready to present?
My fingers are crossed. I'm hoping it'll share the screen.
Yes.
Can everybody see that okay? Okay, great. I think that's ready to start, Matty.
Yes.
Oh, okay. Welcome everyone to Team Blip's final DevOps project. I'm Matty and I'll be kicking us off. Our mission was clear: to enhance the reliability of the vet hospital system, known as the HOSP system, in less than 2 weeks. But why the urgency? Imagine relying on a system that's sluggish and unreliable, especially during critical emergency appointments. That's the daily challenge facing our client with the HOSP system. Our task: to improve reliability while preserving functionality. But here's the catch: we don't have access to the HOSP server, only the load balancer. Despite this limitation, we were determined to conquer challenges and deliver results. So how did we do it? We adopted an agile approach, organizing our tasks into 3 sprints and using a Trello. This enabled us to be responsive during changing events, such as when traffic was ramped up, and deliver incremental improvements throughout the project. To navigate the complexities, our approach was multifaceted. Diagramming updates gave us a visual roadmap of our evolving architecture. By distinguishing between 400 and 500 error codes, we identified the critical impact of 500 errors on server reliability. We set up logging to monitor the load balancer and track changes, helpful for debugging. Also, despite these access limitations, we optimized our infrastructure usage for efficiency. Let's explore our strategies in more detail. Over to you, Dawood.
Thanks, Mai. So our initial approach is we decided to use auto-scaling. We decided this was the most prudent and logical action in order to meet our goals for reliability. This simple diagram shows our system from a high view. Client traffic goes to our load balancer. Our load balancer directs this traffic to our HOSP server, which is running on an AWS EC2 virtual machine. Autoscaling would automatically increase the number of HOSP servers and allow our load balancer to distribute these requests across the servers, and in theory, this would reduce the strain on our server and increase reliability. This would also be cost effective. Autoscaling can not only spin up new EC2 instances when traffic is high, but can also scale down when traffic is low. This would make a more resilient system that would not rely on a single virtual machine.
So the kind of second level of the approach that we took is to kind of look into the visibility of our project. So we wanted to explore kind of different approaches on how we could actually monitor our load balancer that was handling the traffic coming into the host to direct at the host server. So we're kind of keen to understand the nature of the traffic coming in and the volume of it. Are there any patterns that might emerge? So for instance, we're really curious to see if an increase in traffic resulted in certain status codes and if that was anything to do with the reliability. So we experimented with a few methods. One of the first was a program called ZAP, which we'd used in previous weeks. It's great for identifying security vulnerabilities on a website, but we found that it could also be used to increase server traffic as it was making requests to our load balancer to do some of its security testing. But this wasn't as efficient of a strategy, which we managed to fix later. Also, to keep a historical record of the load balancer's activities, we also introduced logging. This has been crucial for us to monitor peak traffic times and manage our resources effectively. Additionally, it gave us the benefit of being able to anticipate issues sooner instead of waiting for things to go wrong and trying to act accordingly. So one of the things that we used is something called Athena, which is essentially an AWS database that pulls data from our stored logs. As you saw in the previous presentation about S3 buckets, that's where our logs were stored. It allowed us to run SQL commands and get a kind of detailed breakdown of the status code errors we were encountering, when they were occurring, and to supplement this, well, as I say as well, so sorry, as you can see, we can show the target status codes here in Athena, and it was really cost effective as well because it only used it per query that you've implemented. And to supplement this information, we also use something called CloudWatch, and this was basically something you can use to kind of use live logging, and we used it to monitor our CPU usage of the load balancer, which helped us understand if our resources were under strain from high traffic and if that correlated at all with any of the error codes that we were seeing in Athena. And some of the successes that were had during these first few days was that we were actually able to find a more efficient way to simulate increased traffic. We used a tool called Postman, which actually lets you set a script to send a certain number of responses and traffic to the host server and receive a status code back. And this was a big step from manually sending the request, as before we were just literally copying and pasting the link. And I think we wore a hole in our mouses just constantly clicking the link to load the pages. So this was a massive boost. We also successfully set up a system for our logs to be stored and interacted with Athena to see the prevalence of certain status codes. We did successfully implement auto scaling, but as the word's going to cover, there was some unintended consequences to this.
So although auto-scaling seemed like the perfect solution for our reliability issues, sadly it didn't react the way we anticipated. After we had successfully launched auto-scaling, our reliability plummeted. We tried a few different approaches. Initially, we did auto-scaling. We manually cloned the host server so that we can add it to our load balancer. We even added our different teams, the other teams' servers into our load balancer to see what would happen. Resulted in our reliability going down. We dug deeper into the data using the tools that we use for visibility, and eventually we realized that the data for the host web application was stored on the EC2 virtual machine. The database was on the host server if you have a look at the diagram. This meant that as requests were going and changing that data, the data no longer was consistent, and that is what led to the plummeting reliability. Outside of auto-scaling, we also faced some issues. We were getting 500 internal server errors, and we didn't know why. Although we cross-referenced these errors with different data sets like CPU consumption and traffic density, we could not find a clear pattern. These failures seemed to be completely random.
Hi everyone, I'm Balázs. So after all that we tried different approaches, some of them worked, some of them didn't. First of all, we updated the diagram and then we jumped into to implement the Lambda function. I would describe a Lambda function as a mini program that you can use for a specific task and throw away in the end, like a disposable camera for a single event. You use it to take photos, and once you develop pictures, you don't need a camera anymore, but it's still there to use it for future events. So initially the Lambda was working and it corrected the errors from the hospital server, but then the next day we realized the success codes were coming back, not the data. So actually it won't be that straightforward. We decided to regroup. James went to investigate how the Nginx works. It might be what we need. The rest of the team kept working on the Lambda. We changed the code here and there, corrected some mistakes. We ran a test, it returned the data and the code what we wanted. So we decided to try it in action. However, the Lambda function did not cooperate as we expected. The only way we managed to make it work to add the credentials to the code, but this is not a good practice. So in the end, we came to the conclusion we have to move forward and try Nginx. I now hand over to James and he will talk about that journey.
Thanks, Balazs. So as you mentioned earlier, we ended up using Nginx as a proxy server. This sat in between the load balancer and the hosp server. And what it would do is every time the hosp server returns a 500, which is a server error, instead of just returning that to the client, it would retry and retry until it returns a 200, which is a success. We tried multiple different configs when we ran this to try to get our reliability all the way up to 100%. And we settled with the script on the left, which got us to about 99.8% overall. This probably was good enough in the end, but we wanted to try get it all the way to 100. So what we did was, instead of having one server, we relayed two. So the stray 0.2% would be caught by another server. This got us to 100% for the whole weekend, which was great. And then what we did on the Monday is we started to try implement some more security and other features. The first thing we tried to do was implement HTTPS because it was currently running only on HTTP. We first tried this by configuring the load balancer to redirect any HTTP request to HTTPS. This seemed to work well because we were receiving 300 codes, which means the traffic is being redirected correctly. However, our dashboard was still showing failures. And what was happening was that the monitoring we were using was returning 300 and that was it, but the server then was sometimes returning a 500, but we couldn't see it due to lack of visibility. Because of this, we decided to remove it and move on with some other problems. Then a few hours later, there was an event which had a huge spike in traffic on our server and we had big problems with performance. What happened was because having two Nginx servers in relay meant that it would exponentially cause performance issues, and this caused us to overload and have a really, really big drop in reliability. What we did to get around this was we split the servers up into parallel and not relay, and then each server would take a split of the traffic, and this pretty much fixed our reliability and took us back up to 100%. After we were now at the 100%, we started to look back at implementing more features to make debugging, testing, and security better. We first started with CloudWatch, which would increase our visibility again on logs. So we had a CloudWatch set up for both our Nginx servers, which would trail the logs. And this means we don't have to go into each server and dig into it to find the logs. And this just makes debugging and security better. We then wanted to get HTTPS working again. So instead of using the load balancer, we used CloudFront. This is a feature that's within AWS and sits in front of the load balancer. So every request will go through this first. And this is really good at kind of doing loads of things at once. So we used it to redirect traffic to HTTPS, but we also used it to cache the websites, like web pages when they weren't updated. So it would increase performance. We used it to reduce code injection. So SQL injection, JavaScript injection, it catches that automatically. And it also adds a rate limiter on to stop like DDoS attacks and high traffic attacks. That was all we did. So moving on to Lloyd, who's going to talk a bit about Terraform.
Yeah, so as James covered there was a lot of different moving parts that we'd set up, and this required a lot of manual configuration to get CloudWatch working and setting up the relevant resources so that they all spoke to each other, so we could get the logs. So what we decided to do is build upon some of the areas we'd learned in the previous weeks, and automate some of the infrastructure being used. And we did this by using something called Terraform. So essentially what this can do is that you can write some configuration files, and just by using a few simple commands, it would basically execute what we wanted to do, and it would build up and destroy what would what had been created as needed and as changes were made to our infrastructure. So you can kind of think of this like giving a list of things to a genie of what you want it to do, and you click your fingers and the genie does it, and it builds it all up magically in AWS. It's kind of witchcraft, to be honest, but it will execute all of that for you. And what this meant is it resulted in the reduction of potential misconfigurations that could have occurred if we'd manually gone into one resource and changed something, and something had gone wrong. We might not have been able to really keep track of that. It meant that all of our infrastructure, well, as much infrastructure as we could was within our code. We would just have to change that bit of code and run it again. This also gave the benefit of later down the line, if we wanted to, we could set up further automation. So we could actually link this up with GitHub or GitLab, and it would mean that when changes were made to that code, it would be automatically deployed to AWS for us, and we wouldn't have to run it manually in our terminal. Oh, sorry, just zoomed out there. Yeah, so as you can see, this is the layout we went for. So we used Terraform to build the resources that would be used by CloudWatch to implement our logs. It created the necessary security permissions that we outlined, the Lambda function that we would need to create. And as Balazs explained, this is just code that's triggered when a certain event occurs. So in this case, when a log file entered our storage medium, which is our S3 bucket, which again, Terraform, we also specified for Terraform to make for us, the Lambda function would then extract the information from that log and send it straight to CloudWatch, which we could then access. So now Dawood's going to speak a bit about our wish list, both if we'd had a bit more time or kind of in an ideal world, what we would have wanted to see implemented for the HOSP server's reliability.
So whether it was at the start of the project or at the very end when we're wishing for more time, there were certain things that were the subjects of our desires as developers. So we wished to have the code base for the web app that we were working on. We actually did not have access to it whatsoever. It would have given us great insight into the workings of the server, how things were routed, what security protocols were implemented, etc. If we had more time, we would have put our web app onto a domain which our clients could very easily remember, a memorable name, something that they can have quick and easy access to. We would have loved to create and implement a pipeline to automate our updates, as Lloyd mentioned previously. This would have helped us build our infrastructure, update our code base, really bring everything together into one solid thing. It would also help us roll back if ever we were making any updates that would affect our system negatively. We could go back to a previous state. We would have also loved to implement, probably this was my favorite, an external database. This would have provided consistency in data regardless of the number of servers we had. We could actually implement autoscaling, and it would have overall provided a more efficient and more resilient system.
Thank you, Dawood. In summary, our journey was remarkable. Despite challenges with very limited access to a not-so-great system and using a host of new and unfamiliar tools, our team's resilience and hard work spurred us on. Every setback became a stepping stone for growth and innovation. We would like to say a huge thank you to our colleagues whose dedication and positivity made this journey so enjoyable. Would anyone in our group like to add anything before we conclude?
That's all. Thank you.
If not, thank you for listening, and we'll be happy to take any questions.
Thanks, team. Once again, huge congratulations for this team for their work, and especially like all the reflections on the different challenges and learnings. And sure, there were a lot in only 2 weeks. So yeah, great job on that. Once again, here for the sake of time, if you do have any questions for this team, please write them into the chat, and they can sort of watch that space and answer if there's any questions there. And finally, the final team to present not only this specialism, but this demo day today would be Matthew, Hadia, Alex, and Henry. Let you the floor to wrap up.
I think you might be muted, Matthew.
I think you're on mute.
Oh, disaster. Good afternoon, everyone. We are Team Bleep. Our motto is bleeping our way to success. we are aware that we are the last of the last, and just want to say thank you to everyone for listening so intently. I'm sure your attention spans are as short as mine is at this point. Over the course of this presentation, we're going to talk about our team, the task we were presented, how we planned, prepped and researched, what we executed, the problems we faced and how we overcame those problems, ending with some reflections, improvements and ultimately a conclusion. Meet the team. There is myself, there is Radia, there is Alex and there is Henry. These are all live photos, by the way. No editing involved in these images whatsoever. We are just that gorgeous. Just want to make a note that Henry isn't speaking today because he's very, very ill. But I just want to make it clear that he has contributed amazingly to this group and to our project. And we just want to give him a big thank you. So on to Radia for how we on the task at hand.
Thanks, Matthew. So as you've heard from the other teams before us, we were tasked with looking after the reliability and the security of this application and this server with essentially no access to anything but the load balancer. So as you can see from this diagram, we couldn't access the source code. We didn't have access to the web server. Essentially all we had to work with was a load balancer. So it was a very impossible task, but we did an incredible job on it, as you'll see through the presentation. So these were some of the essential requirements that we were tasked with at the beginning of the project. So the goals for the week were the ones on the left-hand side: preserve the functionality of the system, increase the reliability, and ensure there are no security breaches. And if we had some time, it would be great to add some of the additional tasks, as you can see on the right-hand side, such as making the service available via HTTPS, store image screening results, tighten up some authorization security for the users, and add an audit trail feature. So how we organised the project, we decided to spend the first day of the week, of the 2 weeks, on the Monday, going through organising essentially the task and what we had to do. So we started by creating a team charter, which included things like when we would have our stand-ups in the morning every day, when we would have our retros, some shared key values between the team as a collective, things like compassion, honesty, patience. We also had the objectives that we were given from the HOSP team and the coaches that were on the charter, as well as our personal and team objectives that we wanted to work towards. And we then also transferred the tasks and tickets onto the Trello board so that it was easy to see and manage, and we can work through them every single day as the project evolved.
So one of the first things we did was begin with a little brainstorm to have a look at all the ways we could try and increase the reliability of our system. Not all of these are relevant, so I'll only talk about what is. But the first thing we looked at was auto scaling, essentially, which automatically adjusts the computer resources up or down to match the demand required. And this looked like a good solution, but we'll get onto that later. And we also looked at the logging, as we felt that would be really important to debug the application. Once we know what's going on, we can start to try and fix everything. So the logs are basically just, you can view the incoming request to the server to gain a little bit more detail on the errors and how we might go about debugging those and fixing them. So we started off with setting up some live logging through CloudWatch, as we felt this was going to be the most useful thing for us to be able to debug the applications, to know what was going on, which requests are failing, which requests are succeeding, so we could work out why certain things were failing and try and fix that. Basically, we got it to within about 5 minutes of live, so very nearly real time, and it really helped to improve the efficiency of our debugging process. We also used a few tools within AWS to analyze the logs a little bit easier, such as Log Insights and Athena, which just allowed us to pass through the data a little bit easier and gain an understanding of what was happening. So once we'd viewed the logs and looked at everything, we decided on going with an Nginx proxy server. We initially thought the best way to do this was going to be using a load balancer, but after doing a bit of research, we realized the configuration we were provided by the hosp team just wasn't going to be compatible with auto scaling, not a load balancer. We had database restrictions that basically meant, I think another team's already discussed this, that you might lose some data when you spin up new instances, because it would also make a new database, which when that instance was spun down would cause data loss. So we ended up going with an Nginx proxy server. It seemed like the best way to move forward. The server essentially allowed us to control the traffic going to the hospital server and catch any errors on the fly and retry those and make sure everything passed.
Another application that we implemented in the first week was CloudFront. CloudFront is primarily a security gateway, you can visualize it as. It was placed in front of the load balancer, and any traffic going into our deployment had to go through the CloudFront. The way it was configured was to encrypt all data from HTTP to HTTPS, basically a more secure form of communication, which was then decrypted back into HTTP by the load balancer to communicate easily amongst all the applications that we knew for a fact were reliable. In essence, this is how we started week one. We were given bare bones system, internet comes in, hits the load balancer, forwards it on to our instance, which contains the hosp server. And by the end of week one, this is what we'd created. We had CloudFront blocking the way, making sure, implementing all of its security measures, doing its encryption, had plenty of monitoring and logging all on its own. We then forwarded this to the load balancer, which decrypted it, allowed for easier communication in our reliable system, and also moved logs to CloudWatch for us to see live. The traffic itself was then pushed onto the reverse proxy server. Again, more logs, more visibility, and a retry configuration setup to try and get past as many errors as possible.
So as you can see, there was a lot going on the first week, and naturally we did encounter some problems, and it's always great to reflect. So some of the problems that we faced was around the AWS resources and the setup. Now, if you've had the pleasure of having to work with AWS documentation, you will know that it is a mighty task to go through. There's about 10 million words, I believe, in all the documentation combined. So setting up some of the 200 plus AWS resources was quite difficult in trying to understand like some of the settings for CloudFront, for Athena, all of the different sort of resources that we were using. Another problem that came up quite a lot is because we didn't have access to the source code. We were essentially debugging blind. So because we couldn't see, apart from the logs and you know, the metrics that we had set up, what was going on, when we were debugging and we were testing, it was us testing sort of without the full context of what was happening. And one of those scenarios when we were going through a debugging process, what had happened is we tanked our reliability down to 5% unintentionally whilst we were debugging. I don't like to, you know, focus just on the problems. As a team, we realized that there were a lot of positives that we took away from the first week. Our monitoring on observation skills were, you know, I think we'd set them up to quite a high standard. We had several streams to view. That was we had Athena, we had CloudWatch, we had Nginx logs, and we also attempted to set up Grafana as well. We were a very adaptable and proactive and calculated team. So all of our responses when we did face errors throughout the week and unexpected events, we thought about it in a sort of calculated approach. We didn't just rush in to make changes. We actually tried to isolate certain things to test and to figure out what was happening. So that worked in our favor quite a lot. And I would say, arguably, we probably had the biggest reliability rebound in Maker's history. We went from 100% to 500% in just under 2 hours, and we still managed to finish the week with 100% reliability. So I think that's one for the Hall of Fame and proud moments in the pub. But as we all know, as developers and engineers in the tech sphere, I think moments of success and joy are very short-lived and very fleeting. We came into week 2 on a high, with obviously a lot of success going on our dashboards and reliability at the end of week 1. And yeah, little did we know there was an avalanche heading our way. So one of the things that we discovered on the Monday of the second week in the afternoon when we were going through our logs was that we were getting a lot of 402 errors, which is essentially unprocessable entity. Now, this, just to point out, when we did speak to the coaches about it, this was the first time they'd ever come across this error in this scenario and the DevOps course that they'd been teaching. So that's great. But essentially what was happening is that we had set up a custom error, a custom token, so like a secret token between sort of our CloudFront and our load balancer for enhanced security to protect us against DDoS attacks and make it more secure. But because we didn't have access to the source code, what this had done essentially is that we had blocked requests from coming through because we couldn't see the full requests and the syntax that was being sent through. So we, found that we were doing this after speaking to the coaches and debugging and researching different things. And we decided as a team and a collective that we would disable this secret token because probably at this point it wasn't necessary, but in theory it was a good, good option to have. Yeah, so that was the reason we were having a lot of errors on the Monday.
The avalanche hits. Kibblegate happens. On the Monday, all teams received the notification that Crufts was going to be revenuing very close to one of the client hospitals. On Tuesday, all teams also received the notice that contestants had been fed contaminated food, and we were expecting a massive increase in traffic. Now, as a team, we were very confident in our system. We'd built it rigorously, carefully, and we'd had a very high reliability over the last week, so we were overconfident. We were wrong. Over the course of about an hour, server traffic increased to nearly 730% of a typical day. We were losing reliability fast, and logs from CloudFront, CloudWatch, and Nginx were full of errors of all kinds.
So as a result of this, we, as you can see from the diagram, had a panic storm, which is essentially us trying to brainstorm what was happening, because obviously we had a tremendous increase of traffic, which we hadn't anticipated. And as Matthew was saying, our reliability and our dashboard stats were pretty high. So we didn't anticipate that this is what was going to happen. So we brainstormed very quickly different ways that we could resolve and react to this event that was occurring. So some of the ideas that we did implement, there were quite a few when we did brainstorm, but we didn't end up using all of them. But some of the things that we did do was we adjusted CloudFront to allow more traffic in at any given time. We also added an additional proxy server to share out the load. We gave the whole system more time to process the requests it was receiving in the different sort of infrastructure and elements. And we upgraded our proxies and the server instance to have better performance memory optimization. So if you could say, we took it from a Lamborghini to a Ferrari. That's the upgrade we made. So as a result of that, despite the 6 times, heavy traffic, crazy amount of traffic that we received, we ended the day with an average of 94.9.7%. Yeah.
So, reflections and conclusions. The things we thought we could improve upon were to set up some alarms in CloudWatch, which would basically allow us to immediately know if we had any spikes in traffic or any potential errors. So in the future, we could catch these things a lot faster and respond to them a lot quicker, just increasing our efficiency as the DevOps team, really. We felt we overestimated our abilities during the Crufts event, which is something we maybe need to look at as a team for next time. So we're not quite so overconfident in our server. although we did fix the problem relatively quickly and get ourselves back up to 100% reliability within the same day. So it was a good response. We just didn't expect anything bad to come of it, I guess. We'd like to have more familiarity with the AWS systems and everything involved. I think that would help us just fix everything a lot easier and have a little bit more of an understanding. But that comes with time, I believe, and just experience, really. And we would have liked to complete a few more of the remaining additional tasks. We did a few of them, but next time we would hopefully get them all done. So future developments, we'd like to change the application to an external database and have more resources that we controlled. It would allow us to work with the server a lot easier. At the minute, we had access to very little, and it made our jobs quite difficult. Better monitoring, much like with the CloudWatch alarms, just so as soon as we see an issue, we can respond immediately. And be more persistent with the HOSP team, just to get a little bit more information out of them if this was to happen again, really. So our points of pride, we did really good research and planning, which really helped us down the line. Our initial brainstorms and Trello boards and everything like that was very beneficial. Once we got started, as we knew what we were doing, we were quick to adapt to any errors, which helped keep our reliability fairly high throughout the weeks. We had really good teamwork and everybody was, brilliant on the team. It was really enjoyable to work with everyone, and we maintained good reliability throughout. Generally, as you can see, there's a few red days there, but overall we did quite well. So thank you for everyone for listening. Anybody got any questions?
All right, thanks team. Congratulations once again for your work and your presentations. Thank you to the whole cloud specialism group as well. I'm super proud of what you've done these past weeks, and really glad that we got to work together on this specialism as well. And congrats to all of the teams from all of the specialism who presented today. I wish I could say more words, but Sean's probably going to hate me if I do. So I'm just going to stop there and hand it back to Sean, who's going to wrap up demo day today. Thanks everyone.
Oh, fantastic. Thanks, Leo. And thank you all so much for joining. And so to everybody who was from Makers today, the presentations were absolutely fantastic. I know it's a big session to go through 2.5 hours like this, but I have to say, every time I thought I might have to tune out, I was absolutely hooked. And I think that's a huge testament. I think a lot of the people who are from outside Makers who joined the call today will absolutely agree with me. Just looking through the chat all day long, people were really impressed, not only by the level of presentation that you guys were providing, but also just some of the things that you were thinking of as you encountered bugs, as you went through your courses, as you went through these final projects. It was really exciting to see. So that is, I think, everything we need to say. To anybody from outside the business, from outside the Makers team, just as a heads up, you will get a recording of the session today. It'll happen next week. It'll be delivered to you not by magic, but in your inbox. And it'll also be on our Makers YouTube channel within the next week as well. So keep an eye on your inbox, watch this space. And of course, that just goes for me to say congratulations to everybody on delivering an excellent round of final projects. And with that, we'll be closing the session. Congratulations and see you all soon. Have a wonderful weekend, everybody.